This is the second video for RobotStudio, and this time we're going to do some more basic operations and also some things that I forgot last time. And so we can just select the same robot as last time and say create. And yeah, I've been doing something already, so I'll say don't save. But for you, you are starting from scratch, and it will be same as before. Okay, so robot is ready, and let's put a tool on it. We're going to use a different tool as last time. So if you go to equipment and all the way down here, there are training objects, and you can select my tool, and so it's here now. And now go to layout, and same as last time, just pull it to the robot and update position, yes. And actually you can also attach it to the robot by right clicking here, and you can just say here attach to. Actually, I'll detach this, and so attach to, and you can say here robot, and so now we have it here. Let's see if it's attached. Yeah, it's moving together, so it works. And now one thing that I forgot previous time. So if you right click on the robot, here you have options for mechanism joint jog and mechanism linear jog. So if we take joint jog first, so this here you can control each individual joint, same as this one, so or similar as jog joint, but the difference is that you have these sliders here. So, and you can see how much like what is the angle on each of the joints. So for example, if you mess up the position, the robot is all lost somewhere, and you want to get it back to its default position, you can just find zeros here or close to zero. So 0, 0. This one was actually on 30 degrees, and 0. Okay, and now you can see we have the robot back here in its original position. And if you want to do it very precisely, if you want to reach something really with some exact configuration, you can also go here. So you don't have to slide it here, but you can click, and here you can set the step. So right now it's 1 degree, so you can see it's going quite slowly, but if you can put, for example, 10 degrees, it goes much faster. And with this you could now put this all to zeros if you wanted. So if I say 1.4, and now I increase this, it goes to 0. So you could do that the same for all of these, but usually it's not so important that everything is exactly in 0 position. And then the second option here, mechanism linear jog. So here this is basically the same as this one, so or these two. So here you are just moving the robot in the coordinate system, and again here you have this step. So it's either millimeters if you are adjusting the position, or degrees if you are adjusting the orientation. So if we put 10 millimeters, for example, it goes faster. So this is pretty nice if you have to make some kind of pattern with this manually. It's quite hard to make it exact, but here you can say you can just move it by, for example, 100 millimeters or whatever the number is, and it can be exact. And same as before, here you have you can choose which coordinate system you are using. Okay, but now let's go to the main thing of today's lesson. So we're going to import one object. So go to import library, equipment, and again all the way down to training objects, and you have this curve thing. So you can click on that. So as you can see, now we have this block here with this shape. And one thing that I think I should also explain a little bit more now is, so back to layout. Here in if you right click on curve thing and you have position, so you have these three options, and I was talking about this a little bit last time, but I think it's better if I do it again right now. So set position, so this is the position of this block, so of its own coordinate system, which is here, in the according to a different coordinate system, to a reference coordinate system. So right now it's world, but again here you can have different coordinate systems. So, and this is just the so it's position, the position of the origin according to this origin of the main coordinate system, and then orientation is just how it's rotated according to those coordinate axes. So I think this is quite understandable, like basic geometry. And then we have offset position. This is also pretty easy to understand, I think. So you can just put whatever number you want here, and you can see it will move it there. And you can also go in space, not in only in one axis. So, and let's, I don't know what, 200. You can see here now it's moving in all different directions, and same here for rotation. You can change the rotation, and again reference coordinate system, you can select same as everywhere else. But then the last thing here, position rotate, is maybe a little bit more tricky, because so again you choose your the reference coordinate system, but then here you have to write the point around which it is rotating. So if I show you, so right now the point around which it is rotating is 0, so it's here. And if I say let's rotate 45 degrees around x axis, so actually I should use the local here. It's going to be easier to see. So 45 degrees around the local coordinate system, this one here. Okay, so it goes like this. But if I undo, and so actually this sometimes happens, this is an artifact, like a visual artifact, so don't worry about seeing this coordinate system still being rotated. It's not, it's just a little leftover. So now if I put some number here, so some different point, so I'll just put some random numbers. So this is now the point around so the point of the origin of the coordinate system. So the orientation is here local, so same as here, but the origin is moved to this point. And if I say 45 degrees now, you can see it didn't just turn up, it also moved. That's because the origin is in a different place. So be careful about that. I think that usually you will have 0 here, because you are usually rotating around its own coordinate system. But maybe sometimes you will need this, so just so you know what this is. Close, and I'm going to undo, so we have this thing back here. And now we're going to make a custom coordinate system. So if you remember last time when we created the first point, it gave us a warning that we shouldn't be building points in the default coordinate system, and that is because if we have this block here, and then we build points on this in the custom coordinate system, and then we go to the real workshop, we are going to have to put this block in exactly the same position as it is here. So if I go here, set position, so we go to the workshop, and then we have to measure these exact numbers. So 1044.73 376 and so on. So, and this is totally unrealistic that this would be we would be able to do this, and because of that we have to create custom coordinate systems according to the objects that we have in the work cell. Because right now we're going to say, okay, this is this block has its own coordinate system, and we're going to do that by just showing 3 points, so here, here, and here. And then when we have the actual robot, we can actually do the same. We can take the robot and show it the position of these 3 angles, and we can say, okay, this is the origin, or this is the coordinate system that we have defined here. And that's why we don't have to, this can be anywhere. It will always know, when we define the coordinate system, it will always know where those targets are. So to do that, we go here to other, you open it up, and you have here create work object. And so first thing we can do here, we can change the name, and it's kind of a convention that when you are naming coordinate systems, so they're called work objects, so you should always start the name with a W. So you can put W, and then right now, I don't know, so whatever you want to call it, I will call it custom right now. So if you are looking later and you through any kind of data, when you see this W, you right away know that this is a coordinate system. So because you can have many different names for different things, but so that's why it's good if you have some kind of convention of starting with some defined letter. And now we're going to put, tell the program where this coordinate system is, and we're going to do that with this user frame. And we can do it by just writing here the position of this coordinate system in relative position to this basic coordinate system. But this is, again, you have the same problem as before, you have to measure it when you come to the real life situation. So the better way is to say frame by points. So if we go here, we open this, and here we have 2 options. So this position is this first one, you tell what's the origin point. Second one, you tell you show 1 point on the x-axis, and then the last one is you just show a point on the xy plane. But I think that usually, well, it depends on the situation. You will just have to see what is better, but in this case at least, this 3 points option is better, because now we can just say origin, then 1 point on the x-axis and 1 point on the y-axis, and this is perfect for that, because we can say here is origin, and then here is a point on x-axis, and here is the point on y-axis. And to do that, we just have to click here, and now whatever point we click, it's going to be saved here. So if I just click somewhere here, oh, actually right now I can't, but oh, so, and there's one thing you have to be careful about. It can be a bit annoying. If you click here, so you can see there is this pointer blinking here. The next thing that you click has to be the point, because for example now I have it here, and now I say okay, I can't see so well, so I rotate my view, and now if I try to click, nothing happens, and that's because I clicked out. So now the robot or the software isn't looking here anymore. And same as this, I often make this mistake that first I click here, and then here we have the selection filters. So then I select the filter. So this, I like this snap object because it snaps to the end of the lines and also to the middle of the lines. And now I try to select it, and nothing happens. And again, so because first I clicked here, and then the next thing, my next click was here on this selection filter. So remember, when you click here to select the point, the next thing that you do, the absolute next thing that you do, has to be selecting the point. So now I have the correct selection filter selected, I have the correct view, and so now I click here, and now I can click on this point here, and as you can see, it saves its position. And now I'll go to the second point. I'll say this is the point on the x-axis. See, it saved it. And now I'll go to the third point, and to say this is a point on the y-axis. And if you click some wrong thing, you can always fix it by just clicking again here. And if I say, so look here, watch here, and now I'll click a different point, you can see it changed it. So if you click something wrong, it's easy to fix. So now I have to go back here. Yeah, and this should be still okay. Yes. And then you can just say accept. And so this object frame, so you should do it in user frame. Object frame is a bit different, so you can now first you have to define the user frame, and then you can define the object frame, and with object frame you can move the coordinate system relatively to this user frame. But usually you won't really need that. I think if you just define it in user frame, that's more useful. But I guess it would be useful if I would say, so I'll create this one now, so you can see it's here, but this object frame would be useful if I would say, for example, I want this to be a bit higher, so that it's offset from this this plane. So then you first have to define this user frame. You get it here, but you don't create it. Actually, I should just do it. So if I define the user frame, 3 point, and yeah, now I'm showing you how not to do things. So now it should work. Yeah, and accept. And now if I say object frame, I can just lift it up by 100 millimeters, for example. Accept. And if I say create, you can see now it's above this. So it can be useful for that, but quite often you can achieve this with the user frame. So now if I go here to pets and targets, you can see, so I'll delete this second one because we don't need it. So here in work objects and targets, you can see we have a new work object. and the one that is in bold lettering is the one that we are using right now. So let's say we want to use this custom one. We can just right click it and say set as active, and I think you can also do it here. Yeah, so you can also change it here in these settings, so you can just choose whichever you want to use at that time. And now this I'll just turn off this selection filter. You can see it's positioned here on this correct point, but if we move this block, it doesn't follow it, and that's a problem because usually you want it to follow it around. So if you have to move something, the work object is going to follow. So I'll undo this so it's back here. And how to put it there? To attach it, you just right click on the work object and say attach to, and you select this curve thing, and now it asks you, do you want to update the position? And you should say no, because if you say yes, it's going to move it to the origin of this. Like this curve thing has its own coordinate system that was with which it was created, and if we say yes here, it's going to move our work object to the origin of the curve thing's coordinate system. So you can see here. So I'm going to undo and say again attach to curve thing, and no, and now it's there. And if I try to move the block, you can see it's staying with it. So now we have our coordinate system, and now we're going to create a path on here on this, so that the path is going to follow this geometry. And we could do it manually, but it's pretty complicated if you want to catch all of these different points. So we have an option here called, so go to path, and you have an option called auto path. And now you can just click on the edge that you want the robot to follow, and it's going to create a path for it. And here this red arrow is showing the direction of the movement, and the blue arrow is showing the direction of the tool's z-axis. So as you can see here on the tool, in the end of the tool, so the origin is in the TCP, and then the z-axis is going away from the tool. And so if here we say, you can see that the blue arrow is pointing down, so that means that the robot is going to approach it from the top. But then if you go like this from the side, so now it's going to come from the side. But let's say right now we want to do it from the top. So you just click on the line, and then you can go to the next one, and it will take the next one and next one, and so on. And then there is an option, if you want to go all the way around, you can just hold shift. So hold shift, and it will select all the way around. Okay, so you can see now it goes all the way around. And then here we have different options. So reverse, if you want it to move in the other direction. And then so remove is if you want to remove some edge, you can just select it and then click remove. And then this reference surface is the surface on which the robot or the tool is going to be normal to. So right now we have this top surface selected, but we can say, for example, if we say this one, so you can see now it's all the time this is maybe it's better if I take this one. So now the robot is going to try to be normal to this surface, but the problem is now, because we are going around, it's all the time trying to be pointing in that direction, and that we can't do. So if you want the robot to go around in that, so that the tool is horizontal, you have to do it already while you are creating the points. So I'll put this now reference surface back here on top, and you can see again we have this. So if you want it to go like this from the side, you have to do it already now. And if I hold shift, actually it won't do it right now, but when you're creating it from the start, you can just say I'll show. Yes. So if I just remove everything now, and now I go like this. Oh, actually, maybe if you are going from the side, you have to click each individual, because otherwise it doesn't know which way it should point. But try it out. Next we have this start and add offset. So this is just so if I say 100 on each side, it's just saying how much later it should start the path. So now it's 100, so this is the original start, but now I said okay, start 100 millimeters later and end 100 millimeters before. But yeah, again, this maybe is not the most useful thing, or depends on the situation, of course. And then these things here are the more important. So this is approximation parameters. So we have linear, circular, and constant. So with linear, it's only drawing straight lines, and so here we have these circles, and it makes these short straight lines. But I think whenever you have some circles, it's better if you select here circular, because the robot can calculate an arc. So to do that, all it needs is a start point, end point, and one point here on the circle. And so whenever you have circles, you should take this, or arcs, not circles necessarily, you should take this circular. And then constant is not too useful, I would say, or again, depends on the situation, but linear is kind of auto mode of constant, because for constant you can just say on how much distance there should, like, it's going to build small paths or distances between the targets, and you can say how far these targets should be. So now it's 10, if we say 20 or 200 for example, it's going to make them like this. But right now, let's go back to circular, and then here we have different parameters. So minimum distance is a parameter that says what is the minimum distance between two targets. So if it would be putting them really close, you can say if you think they are too close, you can say this should be more far away from one point to the other. So if I say here 100 for example, you can see now the distance between each of these points is 100 millimeters. But we don't want that, because now it can't approximate these arcs correctly. So we will put it back to 1 as it was before, because it doesn't use this 1 millimeter anyway, so because this is the minimum distance, but then the software will assess on its own what it actually needs. And then here this maximum radius is the maximum radius of a circle that the software still understands as a circle, because a straight line is basically an arc with an infinite radius. So that's why we have to say this maximum radius, because you can have an arc with a very large radius. It might already look as a even a straight line, but it can still approximate it as a circle. And then this tolerance here is the maximum distance between the actual geometry and the path that it will create. So let's see if this will make any difference. If I say 5 millimeters, for example, no, it won't. But if I say 0.1, let's see, no, it's still same, but maybe it's more use. I can show it more with if I have here linear. So tolerance is 0.1 now, but if I say 1, it should change. Okay, so you can see here it changed because now there are these small gaps here, and now the maximum distance here is 1 millimeter. But if I say 0.1, it has to make a lot more straight lines to come so close. But okay, in circular it approximates these as circles anyway, so this doesn't make any difference. And here in more we have depart and approach. So this is how much it should extend the path of when it's coming to this path and going away from it. So for example, if I say 100 for depart, you can see this path starts already up here, and I can put the same for approach right now. So this path is now going to start already here, not here. And since if you do that, you don't then have to make a separate movement instruction for approaching and departing. And so we can just now say create, and you can see the path was created. And we can now close this. And you can see also same what we were talking about last time already about these zones. So now we have zone 100. You can see here it was created with zone 100, so that's why we have these curves here, but it's okay for now. And now let's see if we can run this. So let's open this, and here open this, and you can see already here you have some warnings, so most likely this won't work, but let's see how it goes. So right click and move along path. And so it's still trying to move, but it won't go far. Okay, so now this is the last one that it can reach right now. And when you have this problem that the robot won't move somewhere, the first thing that you can try is here there is an option view robot at target. So this is going to move the robot to a target that you select. So if I say I have selected this, or you can also do it here, right click and say view robot at target. So and then I select this first target, the robot goes there. And then if I select the second one, the robot goes there. And I'll just deselect this. Why do we have this stuff? Well, anyway. So view robot at target, and now if I cycle through the points, I can see which of the points the robot can reach. Okay, so now target 60, you can see it moved here, but the robot didn't move there. So here it's still moving, but if I come to the next one, it can't move there, and this one also not. And now again this one it can come, again not, and so on. And this is because the targets aren't reachable for the robot. That actually these warnings here are showing. So this red one means that it's not reachable at all, and then these yellow ones are that it's reachable under different configurations. And actually I'm going to explain a little bit later what different configurations mean, but just so you know that these warnings mean that the robot can't reach these positions. How we can check that? Actually here you can go back to layout and the robot, and then here we have an option show work envelope. So, and then we can deselect 2D outline and put 3D volume. And so this bubble here is showing the volume of where the robot can reach. So if it stretches all the way out, and actually here we should put active tool. So if it reaches all the way out and moves all around, this is the outline that the TCP of the tool is going to draw. And we can see here that actually this whole block is inside this bubble, or so it's called work envelope. And so we don't have to move this block, but we can do something else to make it reachable. And let's turn this off now and go back to paths and targets. And now there is one more option. So before we had view robot at target, but now we can have also view tool at target, and we select the tool. Now it's only one, so we select that one, and I'm going to move the robot a little bit out of the way so it's a bit easier to see. And now if you click the tool, or sorry, click the target, you can see how the tool is going to be positioned at that point. And you can see now it's moving around quite a lot, and here in the back it's pointing away, so it's clear that the robot can't so here the robot can't reach this point in this direction, so that it would have to, the arm would have to be coming from this direction. And what we can do now actually is we just select all of these points, and now we can see here how the tool is oriented in every position. And if the tool would be oriented like here, like this one, through the whole thing, it would be able to reach it everywhere. And also it's like turning around like this, it's just unnecessary movement. So we're going to copy this the orientation of this tool from here to all of these other points. And so this one that is pointing that way, I think is this last one, yeah. So if we say right click here and we have copy orientation, so that is the orientation of the tool. So copy orientation, and now select all of these points and say apply orientation. And now you can see here all of these tools are pointing in the same direction. And now if we try to run this path, it should work. So you can see it's moving, like it's the tool is staying in the same position the whole time, and it's still moving around, because, and it's okay because this is some kind of, I think it's a glue applicator or something like that, and the tool doesn't have to rotate around to do the work. It's symmetric, so it doesn't matter how it is oriented. if you accidentally make targets in the wrong coordinate system or work object. So for example, if now I would want to, I made them in this custom, but I would want to do it in this one here. You can move them between those, and you can do that very simply. You can just select all of them, or the ones that you want to move, and just pull them to the other work object. And now here it's asking you, do you want to reposition the target? And if you say yes, it's going, the coordinates of the targets are going to stay the same, but because it's going to move in the different coordinate system, the actual position of these targets is going to change. And if you say no, the position of the targets is going to stay the same at this exact place, but it's going to the coordinates themselves are going to be changing. So I'll just show you. If I say yes here, you can see this whole path now moved here, because it recalculated, or it didn't recalculate the position, the number stayed the same, only the coordinate system changed. But if I undo this and I try again and I say no, so now these targets are in this other work object, but the position stays the same, because it just now it recalculated the position, or the coordinates of the targets. But we want them here in the custom, so I'm going to put it back here. I'll just undo, so now we have it here again. And we want this path to move with the, if we move this block, we want this path to move also. So right now it's moving, because before we attached this work object to the block, and these targets are attached to this work object. So work object is attached to the block and targets are attached to the work object. So if we move the block, also the targets are moving. But if we have the targets in a different coordinate system, no. So, and now if I move the block, the path is staying at the same place. And this is why it's important that you are putting them in the correct coordinate system. And one more. Okay, so one last thing, there is one more way how you can create targets, and that is to just write the coordinates of the targets in the directly in the software. And let's put here to work coordinate system. And how you do that is, so you go here to target and you have create target, and yeah, it's warning again. So reference is the word, and now here you just put the coordinates of the origin, and then here is the orientation. And if I say, for example, here, let's put them 1 meter in every direction away from the work object, and we should also rotate around X, or actually I'll show you. If this is 0, if I say add, and then I have to say create. So if the orientation of the z-axis is 0, that means that it's pointing up. And now if we see the tool at target, you see it will have to be pointing up. So what you should do, if you want it to be pointing down, you have to put here orientation 180. So if I put it so let's say this one can be 800, but then these other ones can be 1000, same as before, and then this one is 180, and let's say add and create. So you always have to, even though you say add here, so you can add here a few different targets, add, so you can make a bunch, then you always have to say create, because otherwise it won't make them. So, and as you can see now, they are pointing downwards. So you have to be careful with that when you are creating the targets manually. And because of that, if you can teach the targets with the robot, like moving the robot and then say teach target, that is usually the better option. This is, if you have to have some really defined geometry, you can use that, but otherwise it's always faster to create it by like manual method. And there's another reason for that. If we say, well, let's delete this first one because it's pointing in the wrong direction, but otherwise we say let's create a new path with these, add new path, and let's turn off this tool at target, and we open this. I got lost. Or wait, is this actually not reachable? Let's see, robot to target. Oh yeah, it's not reachable because, yeah, it would have to be pointing in that, so the robot would have to be in that, coming from this side. So I think it's still in the work envelope, but let's rotate them. So I can say modify target and rotate. So local around origin, and we can say 90 degrees around Z axis, and let's say apply, and once more, oh yeah, now it's correct. So X is pointing this way, and let's take this other one and say also apply. Okay, so now X is pointing this way, and so the robot can reach. So this is another problem that you have with manual. And let's turn robot target off, and let's say this runs. So move along path. Okay, it works. So this is actually an improvement in this latest version. So what I was going to show is different configurations. So configurations are, actually I have to go to target. There are different ways of how the robot can reach this target. So here we have 4 different configurations. So usually this first one is the best. It's the most the robot has to make the least weird motions to access it, because if you look at these other ones, so this one is still okay, it's only this joint is here rotated, but then this is you might have to use it if you have to avoid some collision here, but otherwise this is not very useful. And then this is the same. And before when you created points manually, you had to also manually tell the robot what configuration you want to use for it, but I guess now in this newer version it calculates or chooses the configuration manually. And one thing how you can also decide about what's the best configuration is to check here. So this is the displacement of the joints. And if you look at them, it should be the configuration that has the smallest numbers. So the robot has to rotate the least to reach it. So for example, here you see these are quite low, all are relatively close to 0, but then if you take this next one, you have these two that are 100 something. So the first one is the correct one, and so we'll just say apply. So, and before, when it was, if you remember, there were these yellow signs here showing, so if it's a yellow triangle, it means that the robot can reach that point, but it needs a different configuration to reach it. And if you have that, you can just right click and here modify instruction and configurations, and now you can also change the configurations for this single move instruction, so it won't affect the target, but it will only affect this move instruction. And then you can select one that works, and then the robot will be able to reach the point. But I think that is all for now. Same as last time, try different things. You will learn most when you are just exploring on your own. I'll see you in the next video.